Okay, so today we are doing 7.35. Your goal for today is to be able to convert rational. Rational means a fraction. In Algebra 2, you learn about rational functions, which are functions that have fractions, like where x is on the top and the bottom of the fraction. But rational exponents, which means that the exponent is a fraction. So if you look at the one on the board, I just wrote that up there so that you know how to type in for your homework, but we'll be talking about how to convert from rational exponents to radical. Radical means like square root, cube root, anything that has a root with it, that's a radical function because it has the square root symbol. Lucas?
Would you consider this lesson easier than yesterday's?
Yesterday you did the OST questions.
Yeah, but like the lesson before that.
The geometric sequences.
Yeah.
It's just different. They're both different, and the reason that they have like the 3.5 and 5.5 is because they're not actually lessons in the textbook. They're like 1 page or 2 pages of like extension in between. So that's why it has 7.35 and 5.5. But they are still on the OST, and they're still important to learn for geometry and Algebra 2. Okay, so number 1, hopefully you did these questions already. Number 1, answer is 7. Number 2, square root of 121. Jacob? 11. Number 3. Emily? Yes, 2 to the 5th, and 2 to the 5th is, what, 32? So you can simplify that to be 1 over 32, and then 13 squared is 169. Well, I'm going to have to edit this video. Hello, this is Billy. He is absent today. Yeah. All right. Okay, so the rational exponent rule. You can write a square root of a number using a radical. And for any non-negative number a to the 1/2 is equal to the square root of a. Probably not going to be able to find my notes. That's okay. That's all it says. Okay, so we're going to practice. Actually, let me write another way. That's the general case, and that's the most basic one is 1/2. So 1/2 means a square root. But in general, if we have a to the n over m, so that means the exponent is a fraction. The m is the root. So like here, the denominator was a 2. That means a square root. So this is an implied a 2. We don't normally write the 2 there because it's implied to be a 2. But for any other number, it would be the mth root. So the denominator of the fraction represents the root of a. The numerator of the fraction represents the exponent. So I'm going to put parentheses around the root to the power of n. You can also write this a different way. You can write this as the cube root, the mth root of a to the n. You can write the n on the inside of the radical. But this way is the way I would like you to write it for your homework because it helps us to simplify it easier. Because then we'll take the cube root or the 4th root of whatever number we have and then raise it to the exponent power. And that makes it easier usually. But either of these are equivalent. This is the way I want you to write it for your homework. Okay, so the denominator represents the root. The numerator represents the exponent. So let's practice. If it's 1/2, then it's just a square root because the 1 is the exponent and an exponent of 1 doesn't do anything. So 1/2 just means square root. So this would be the square root Did I miss some questions?
Yeah.
Oh man, okay. Okay, so the first one says 16 to the 1/2. So first we are going to simplify or convert it into radical notation and then simplify it. So this means the square root of 16, which is 4. So it's important to write both of these, the radical part and the answer. Jack?
Why did you not put the 2 in the 1 there?
You don't need the 2 because a radical without anything means square root. And the 1, if I do anything to the first power, that's just itself. So the next,
Why don't you need the 2?
because this means if you don't have a number there, it's implied to be a 2. Right? Whenever you see a square root, that means a square root, which means you need 2 of the same thing under the radical. If it's a different number like 3, that means you need 3 of the same thing. Like those are your cube roots. So cube root of 8 means 2 times 2 times 2. I can rewrite 8 as 2 times 2 times 2, so the answer would be 2. Because there are 3 2's multiplied together under the radical. Okay, the next question is 25 to the negative 1/2. Now, since it's a negative exponent, we need to put it under 1. So 1 over 25 to the 1/2. And 1/2 means square root. So this would be 1 over the square root of 25. And the square root of 25 is 5. So this would be 1/5. Not 5. Or not negative 5. The third question is 9 to the 5/2. Okay, 2 is the denominator. That means it's a square root. 5 is the numerator. That means the exponent will be 5. So first we're going to rewrite this as the square root of 9, but then it's being raised to the 5th power. So let's simplify this. Yes.
How do you know if the exponent goes on the outside parentheses or?
I told you guys to always put it outside because that helps us simplify it. Because we first want to take the square root of 9. We don't want to raise 9 to the 5th power first. So the square root of 9 is 3. And then 3 to the 5th power would be 3 times 3 times 3 times 3 times 3. So 3 3's would be 27. And then another 2 3's would be 9. And then you would do 27 times 9. Can you figure out what 27 times 9 is? What's 27 times 9? Do you have a calculator? Okay. 243. You do 25 times 9 and then add another 18. Okay.
So why would you start doing the 3 to the 5th? Is that just an example?
Well, the square root of 9 is 3. So I simplified it as 3 to the 5th. And then I figured out what 3 to the 5th would be. Okay. And then the fourth question from that section is 4 to the negative 3/2. So since it has a negative exponent, we're going to first put it under 1. Like that. And then we're going to convert it into radical notation. So the denominator is still 2. That means it's a square root of 4. But the numerator is 3. That means we have to put 3 on the outside as an exponent. Okay, and then we're going to simplify it. So the square root of 4 is what? We have to do order of operations. 2. And then 2 to the 3rd power.
6.
No, 8. So answer is 1/8. But make sure that you also are writing this on your paper. This part is just as important to me as this part because that's how you have to write it on your test too. All right, I'm going to give you a minute to 2 minutes to do the you try questions.
What
will we get through this lesson today?
Yes.
Will I have to make another video today?
Okay. Let me just keep this.
Jude, put number 1 on the board, please. Can you put your answer number 2 on the board, please? Can you put your answer to 3 on the board, please? Check the board for your answers. 2. Make sure you guys are writing. Remember, it's really important that you write the root. So you write it in radical notation and the final answer. Because the homework is going to ask you to write it both ways. So you have to show your steps. You want a sticker? You write your answer number 4 on the board.
First you have to do this. Alright.
And if the square root of 4 is 2, then you can do 2 to the 7.
Wait, which one?
Make sure that you're writing the answer and this part.
Always.
Okay?
So for this.
So number 1, just going to check your work on the board, please. I'm just going to copy it down.
So first you solve this. What's the square root of 36? Okay, so 6 right here. And then -1 power. So you don't really need that 1 because anything with the exponent of 1, it just stays the same, right? Yeah. So all you need to do is look at this exponent.
Okay, once you're good, you can flip your page over.
1 over 6.
Okay, so that page was just on square roots. The only thing that we're going to be doing is square roots and cubed roots today. Well, for Algebra 1. So this page is on cube roots. So if b cubed equals a, then b is the cube root of a. For example, 2 to the 3rd equals 8. So 2 is the cubed root of 8. So basically whatever time multiplied by itself 3 times is equal to that number. The cube root of a can be written like this. Now since it's the cube root, the 3 is the root, so we write it as a to the 1/3, or you see it as a to the 1/3. So anytime you see something to the 1/3 power, that just means a cubed root. So evaluate the expression involving cube roots. So for part A, this would be written, we're going to write it first as the cube root of 27. Now that it's not a square root anymore, it's important that we write the 3 at the root. And then the cube root of 27 is 3. For part B, negative exponent means we're going to take the reciprocal first. And it's to the 1/3 power, which means it's the cube root of 8, which is 2. All of the perfect cubes from 1 to 10 are on the board over there. So you have that as a reference. Okay, so 64 to the 4/3 power. The denominator is 3. That means we have the cube root. We're going to write it as the cube root of 64, but then it's to the 4th power. So we have to put parentheses around it and raise that to the 4th power. Remember, this is how you need to type it in on the homework. And then you evaluate it. So you do inside the parentheses first. What's the cube root of 64?
4.
Jude? 4. And then you do 4 to the 4th power. Well, 4 to the 4th power would be 64 times another 4. Oliver? Yes.
Dude, stop sweating. You have to calculate.
It's also, you guys, this is also 4 squared times 4 squared, which is 16 times 16, and 16 squared is 256. Okay, part D, negative exponent means we're going to flip it. So 1 over 125 to the 2/3 power, and that means 1 over the cube root of 125, but then we have to square it because the exponent is 2. So denominator is the root, exponent is, numerator is the exponent. All right, cube root of 125 is 5. So then you have 1 over 5 squared, which is 1 over 25. And then you can do the U-try questions. You put that answer on the board, please.
Number 1. Yeah.
Is up there. It's one of the perfect cubes.
Wait. What was the first question? I forget. My favorite teacher.
You want to do 3. Make sure you write the radical and then the answer.
I actually don't know.
I'm sorry.
It's a hard one.
Can you put your answer to 4 on the board? Okay.
What are you talking about?
You guys, 64 is a perfect cube. The cube root of 64 is 4. That means 4 times 4 times 4 is 64.
I don't know. Is it? You should figure it out.
By the way, you do have homework tonight. It is 7.35. It is the last, this is the last lesson of chapter 7, and then we will have a test on Tuesday.
Tuesday?
Yes.
Tuesday. What if you have snow down Monday?
We're not going to have a slow down Monday.
You don't think so?
Okay. So 1 over, cube root of 8.
Flush ice down your toilet, please.
Monday.
Not doing it.
Wednesday.
Okay. So you guys good on those answers? If you're not, go ahead and fix what your answer was. And we have a couple minutes to try some of those last questions on there. Just for fun. Okay. So I don't have them on here. Part A. 12 to the negative 1/2 times 12 to the 5/2 is equal to 12 to the what power? When you multiply powers at the same base, you add the exponents together. So 12 to the what power? Jude?
Here.
Negative 3. It's to the second because it's to 4 halves. Negative 1 half plus 5 halves. It's 4 halves, which is 2. So this is 12 squared, which ends up being 144.
Oh my god.
Okay, B. 6 to the 4/3 times 6 divided by 6 to the 1/3. Okay. I would look at this. Look at this part first. What's 4/3 minus 1/3?
1.
1. So if you simplify this, you get 6 to the first times 6, which is 36. Don't worry, these won't be on your homework. They're just for fun. And then for part C, if I add those again, I would get 8 to the what power? 1 half minus 5 halves would be, negative 2. But 8 to the negative second does not mean negative 64. It means 1 over 64. Because it's 1 over 8 squared. And then answer to the last question. This is really easy. Because the 3 to the 0 cancels out because it's 1, and then 5/3 minus 2/3 is what? Lucas?
4.
5/3 minus 2/3
Yeah. 1.
is 3/3, which is 1. So it's 3 to the first power, which is 3. The answer is 3. So complicated expressions that simplify to something really easy. That is like a lot of what math is. Okay, you guys have homework. I will assign it. You've got about 1 minute left until the.
Oh, it's time to go.
No, 9:37.